The standard form of a quadratic equation is ax squared plus bx plus c equals 0. In this equation, a, b, and c are coefficients. The coefficient a must not equal 0, otherwise the equation would not be quadratic. To solve for x in a quadratic equation, we use the quadratic formula. The formula states that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's break down the components of this formula. The term negative b is simply the opposite of the coefficient b in our original equation. The plus-minus symbol indicates that we'll get two potential solutions from this formula. Under the square root is the discriminant, b squared minus 4ac. This term determines how many real solutions our equation has. Finally, everything is divided by 2a, which is twice the coefficient of the squared term. The discriminant, which we often denote as delta, is the expression under the square root, b squared minus 4ac. When the discriminant is positive, the quadratic equation has two distinct real solutions. When the discriminant equals 0, there is exactly one real solution, which is a repeated root. When the discriminant is negative, there are no real solutions. Instead, we get two complex solutions. Let's visualize how the quadratic formula works by looking at a parabola. For the quadratic function, y equals x squared minus 2x minus 3, the quadratic formula helps us find the x-intercepts. Using the formula, we can determine that this function has two roots, x equals negative 1 and x equals 3. These x-intercepts are the solutions to our quadratic equation. The plus-minus sign in the formula gives us both of these values. The plus sign in the formula gives us one root, while the minus sign gives us the other root. The quadratic formula is a powerful tool for finding the roots of any quadratic equation.